Hello everyone, I hope you all are doing great. We heartily welcome you all to our YouTube channel cadcaemaster. If you enjoy what you see, hit the subscribe button and turn on the notifications so you never miss an upload. Well, so agenda here is to deal with the different types of CAE softwares available in the market. So we'll see about the pre-processing, processing and the post-processing, what exactly they are and how do we need to deal with them. And then we'll also see the types of elements and the types of mesh available in the different tools. Well, let's get started here. Yep, I hope you could see the screen and my laser pointer as well. So when it comes to CAE softwares, so we have the different things into account. Like in the analysis, we have the pre-processing, post-processing and the processing, that is solvers. So depending upon the requirement, we have the different tools. Okay, let's say in the market right now, for the pre-processing, we have the different set of tools for advanced meshing activities and modeling activities, like thousands of components. Let's say if you are working with the automotive industries and all, so you are going to work with the vans, the trucks, the cars, and the bikes, so different things. Okay, even the small scale industries, medium scale industries. So in that case, we need to take the entire CAD model, all the parts, and then mesh them into components, and then the forging components with respect to the solids and the sheet metal components with 2D meshing. So this is all comes under the pre-processing activities. So where we use the model build activities, the tools like the ANSA, okay, and the hypermesh. So we use them to mesh the models. So in the market, these are pretty advanced. Even we can use the ABAQUS and ANSYS, but yeah, in the current market, Germany and Japan, so even China, so even in India, so many people are using hypermesh, ANSA and ANSYS predominantly. Just remember that. Okay, when it comes to, I was talking about the CAE software, yeah. So we'll just jump into the different types of analysis, what we do in the steps in the analysis actually. Okay, in the pre-processing, the first one, so we do the model build activities as I explained now, and then we define the material. Okay, for the different components or the different parts, we define the material, and then we mesh the model. Okay, so with respect to 1D, 2D, 3D elements, we mesh the models, and then we define the boundary conditions, linear, non-linear, dynamic. So all the things will be included, the fixtures, okay, everything will be included here, the pretensions. So most of the things will be included here. Once you define, or once you are done with the pre-processing, we'll go to the solvers. So in the market, there are some tools which directly do everything, simple tools. So let's say static analysis, simple model analysis, a thermal analysis. Yeah, these kind of things will be done in a single software like the SOLIDWORKS, and even we have the CATIA and then NX, Siemens NX, SolidEdge. So these all the tools we can directly take. There are of course some solvers are also there. So yeah, just for information, so we have these tools, so where we can model, mesh the model and run the analysis and even post-process it, like the SolidWorks simulation and the NX. We have the Nastran tool for the solver as well, and then we have the Siemens NX simulation tool as well. Yeah. Yeah, so in ANSYS we can do everything. Yeah, in ABAQUS also we can do everything likewise. Okay, but depending upon the requirement we have it. So let's say if you would like to run the crash analysis, and also we have the LS-DYNA radius and all, right? And then if you would like to run the ABAQUS, the durability analysis and all, we have the FEA tool. Okay, so likewise, as per the requirement, we have the different solvers. So even for the explicit and implicit, we can call it. Yeah, so let's say OptiStruct we have it, Radius we have it, likewise ABAQUS, Nastran. Yeah, So these are the independent different solvers, we can say. So you do everything and define the NAS or FEM files and just load it here, and they will solve the results, and then they will give it for the post-processing. Yeah, the post-processing, so as I told, some standalone softwares are there. So only the basic analysis, simple analysis you can do it and you can visualize, but when it comes to the complex models and also we need the independent tools where we can able to view the results, okay, in the form of the stress plots, displacement plots, the counter plots, animation, some of the PCH curves and all, everything we can able to do it in the post-processing tools. Likewise in ANSA we have the meta, right? In Altair tool we have the hyperview, ABAQUS we also have it, yeah. So likewise in ANSYS we have it in all the softwares, but predominantly we have the Altair hypermesh and the ANSA meta, but 90% of the people use the hyperview to post process the results. Okay, I hope you got the different steps in analysis, and depending upon these we have the CAE softwares. Let me take you through that. So I hope you can see my screen. So here, so list of CAE softwares, as I said. So with respect to the operating system, we have the developers and the softwares. So as I told, ABAQUS from the Dassault system, we use it most predominantly. We have the beta CAE tool, that is ANSA preprocessor. I think most of the OEMs are using it, most dominant tool. And ANSYS also for the aerospace and the medium scale industries, industrial equipments, we use it. Yeah. Similarly, we have the Autodesk, different tools are available also there. And then yeah, so likewise we have the Cosmol industry, the Creo tools, simulation tools also available there. And then we have the mold flow for the flow analysis, the plastic flow, and even we can even do the forging, the flow analysis, yeah, casting, sorry, casting, yeah. And then Siemens NX, as I said, and then we have the SimScale, SolidWorks simulation, we have it from the Dassault system, as I said. So we have the Solid Edge. Likewise, we have the multiple softwares. Okay, so depending upon the requirement, all the Linux or the Windows versions are also available. So this is clear for you guys. So in short, to conclude here, the in the industry currently, the predominant tools are the ANSA, as I said, the pre-processing, ANSYS, ABAQUS, and the hypermesh tool. So as far as I know, so these are trending, and most of the advanced analysis will be done in these tools. Or for the medium scale industries and the small scale industries, they use like SolidWorks simulation and other tools to do their regular activities. But for crash, durability, NVH analysis and all, so these ANSA, hypermesh, ABAQUS, LS-DYNA, these kind of all advanced tools are necessary. Okay, I hope this is clear for you guys. So what exactly the CAE softwares? So there are a lot of things to learn, but don't get confused. In short, we have the pre-processing, we have the independent tools and the standby tools, and here also for the processing we have the independent and standby. For post-processing also we have the independent and standby tools, and all included also we have the tools, okay, where we can model and run the analysis. Likewise simple, okay, not the complex geometries and all, the more than not like single components, or simple assemblies also we can do it in that, okay, like the SolidWorks simulation. And even we have the Siemens NX tool, and then we can even do there everything in one software. Yeah, let's move further. And now here, when it comes to the types of elements, very important. So elements in the CAE world, we have the 1D elements, 2D elements, and the 3D elements. 1D, we have the simple bar. So with respect to the number of nodes, we have the different the 1D elements. Okay, so when it comes to 2D elements, we have this triangular, we call it as tria, okay, and this also comes under 2D elements. Yeah, and then we have the quadratic triangle, linear quadrilateral, we call it as quad elements. So most predominantly we have the trias and the quads in the most of the CAE world, okay, we use them. these are the, see, if you have 3 nodes in the triad, it is a first order element. If you have the 6 nodes, it is the second order element. So where it can fit the complex geometries, but 90% of the simulation are done on the first order elements, like the quad elements and the tri elements. Okay, so even we have the second order 9 quadratic elements, okay, and then 8 quadrilateral elements. Yep, so these are the few 2D elements. When it comes to solid elements, that is 3D elements, we have the as I told, so one is the tetrahedron, linear prism, so linear hexahedron. So we use most of the times the tetrahedrons, hexahedrons, and the pyramids. So while meshing this one, so we will also have the pyramids in the model, so remember that. Prism also, and the hexahedron also will be there likewise. Okay, so these are all the solid elements, 3D elements we can call it, and taking these all the things, we mesh the model. Okay, so when it comes to mesh, so we call it as triads and quads. When it comes to 3D, we have the tet mesh and the quad mesh. Okay, so likewise we have the prisms, pyramids, and the arbitrary polyhedrons. So most of the case we have the tetrahedron and the quadrilateral elements. I hope this is clear, but 90% of the cases you are going to deal with the tri elements and the quad elements 2D. Okay, so a solid, we have most of the cases tetrahedral elements everywhere. Some complex geometries consider this hexahedron, but not more. 90% you're gonna get it tetrahedron. I hope it's clear. Yep, so this is all about the session. So we had went through the CAE softwares which are available in the market. So we had seen what exactly we do in the post-processing, the pre-processing, and the solver stages. We had seen the different types of elements and the types of meshes. And in the next session, we'll be covering the model build activities.
We heartily thank you all for watching this video. If you enjoyed this video, don't forget to hit the subscribe button and give it a thumbs up. Follow us on Facebook, LinkedIn, and Instagram for behind the scenes content and the updates. Stay curious, stay awesome, and see you again in the next video.